Welcome, and thank you for joining me. I'm so glad you're here. Before we start, I'd love it if you could share in the comments where you're watching from and what time it is for you right now. It's always fascinating to see the range of times and places represented here. Thank you also to those who continue to subscribe and show their support with likes. It really guides me in shaping this space and helps others discover it too. If you have ideas for future videos, please let me know in the comments. With that, let's begin. Chapter 1: Understanding Infinity, a Conceptual Overview. Infinity is a concept that has captivated the minds of mathematicians, philosophers, and poets alike for centuries. It is a notion that evokes a sense of wonder, stretching the boundaries of our understanding of the universe. To grasp infinity, one must first explore its definition and the historical context that has shaped its meaning over time. The term infinity derives from the Latin word infinitas, which means unboundedness or endlessness. This idea can be traced back to ancient civilizations, with roots in the philosophies of the Greeks. The philosopher Anaximander pondered the idea of the apeiron, or the infinite, as the source of all things. He suggested that the universe emerged from this boundless realm, emphasizing that the infinite was more than just a number. It was a fundamental aspect of existence itself. As we journey through history, we find that the conception of infinity has evolved significantly. In the Middle Ages, scholars like Thomas Aquinas debated the nature of infinity in relation to God, viewing it as an attribute of the divine. They believed that God was infinite in wisdom and power, and this theological interpretation laid the groundwork for understanding infinity in a broader philosophical and mathematical context. The modern mathematical perspective on infinity began to take shape in the 17th century, with the work of mathematicians such as Galileo Galilei. Galileo introduced the idea of different sizes of infinity when he observed that the set of natural numbers, though infinite, was smaller than the set of points on a line segment. His assertions sparked discussions that would continue for centuries, challenging the notion that all infinities are created equal. Fast forward to the late 19th century, when the German mathematician Georg Cantor revolutionized the study of infinity. Cantor introduced the concept of countable and uncountable infinities, distinguishing between sets that can be matched with natural numbers and those that cannot. Imagine trying to pair every person in a room with a unique number. If there are only a finite number of people, the task is straightforward. However, if the room is filled with an infinite number of people, the situation becomes more complex. Cantor's insight revealed that not all infinities are equal, as the set of real numbers is uncountable and cannot be matched one-to-one with the natural numbers. This distinction gives rise to a fascinating question. What does it mean for something to be uncountably infinite? To illustrate this concept, envision a vast library containing every possible book that could ever be written. If you were to count the total number of books, you could theoretically reach infinity. However, if you consider all the possible arrangements of letters in a book, the number of combinations becomes uncountable. This realization opens the door to a deeper understanding of the infinite, suggesting that there are realms of existence that transcend our ability to measure or comprehend fully. Philosophical implications abound when we consider infinity in mathematics. It challenges our intuitive understanding of numbers and reality. The mathematician David Hilbert famously stated, "Infinity is not a number," a notion that prompts us to rethink how we perceive mathematical constructs. Infinity serves as a tool for exploring the infinite expanses of mathematics, yet it also raises profound questions about existence and the nature of the universe. Infinity invites us to ponder our place within the cosmos. It encourages reflection on the finite nature of human life compared to the vastness of the universe. When one gazes at the night sky, filled with countless stars, it is impossible not to contemplate the limitless possibilities that lie beyond our reach. Are we merely a fleeting moment in the grand tapestry of infinity? In the realm of mathematics, we encounter key figures who have significantly contributed to our understanding of infinity. Besides Cantor and Galileo, we cannot overlook the influence of Kurt Gödel, whose incompleteness theorems revealed that in any mathematical system, there are truths that are inherently unprovable. Gödel's work implies that our understanding of infinity is not only vast, but also layered with complexities that challenge the very foundation of mathematical logic. Each of these thinkers expanded the horizons of how we perceive and engage with infinity. They have encouraged us to question the boundaries of knowledge and existence. As we explore the depths of infinity, we find ourselves at a crossroads where mathematics meets philosophy, prompting us to ask, how do we reconcile our finite experiences with an infinite cosmos? As we draw our thoughts toward the implications of infinity in mathematics, the idea of limits emerges as a crucial element. Limits allow mathematicians to approach infinity in a manageable way, providing a framework within which one can explore infinite sequences and series. Consider the concept of approaching a limit, wherein one can get infinitely close to a value without ever actually reaching it. This idea is not just a mathematical abstraction. It resonates with the human experience of striving for goals that may seem perpetually out of reach. The exploration of infinity doesn't merely reside in abstract mathematics. It permeates our understanding of the physical world as well. In physics, infinity arises in discussions of space and time, particularly in theories like general relativity. Imagine the fabric of spacetime, a vast and intricate expanse that bends and curves in response to mass. This conceptualization challenges our perception of the universe as a bounded entity, suggesting instead that it may extend infinitely in all directions. Infinity can be a source of comfort as well. The knowledge that the universe is boundless can inspire a sense of peace, reminding us that our individual lives are but a small part of a grander narrative. It whispers to us in moments of solitude, encouraging us to reflect on our existence and to find beauty in the fleeting. The journey through infinity also leads us to consider paradoxes that challenge our understanding. The famous Hilbert's Hotel paradox illustrates this beautifully. Imagine a hotel with an infinite number of rooms, all occupied. If a new guest arrives, the hotel can still accommodate them by moving each existing guest from room 1 to room 2, freeing up room 1 for the newcomer. This paradox reveals the counterintuitive nature of infinity and how it defies our conventional logic. As we ponder the philosophical implications and the mathematical intricacies of infinity, we cannot forget the profound impact it has on our understanding of the universe. It serves as a reminder of the limits of human comprehension, inviting us to embrace the unknown and to remain curious. The mathematician and philosopher Bertrand Russell once remarked, "Infinity is a concept that is both fascinating and perplexing." In our quest to understand infinity, we are reminded that there is beauty in the exploration. It encourages us to appreciate the vastness of knowledge while recognizing our own limitations. As we journey through the realms of mathematics and philosophy, we become more aware of the mysteries that lie ahead. Imagine standing at the edge of a vast ocean, the horizon extending infinitely before you. Each wave that crashes upon the shore represents a new discovery, a new question to ponder, and a new layer to uncover. This imagery encapsulates the experience of engaging with infinity, a journey that evokes both a sense of wonder and a deep yearning for understanding. In this exploration, we have only touched the surface of infinity. The journey is ongoing, filled with questions, discoveries, and a profound sense of connection to the universe. As we continue to delve into the realms of mathematics and philosophy, we encourage listeners to embrace the concept of infinity as a guiding star, illuminating the path toward deeper understanding and appreciation of the boundless wonders that surround us. The exploration of infinity also nudges us toward the notion of continuity, a concept that plays an integral role in mathematics and philosophy alike. The idea of continuous quantities invites us to visualize a smooth, unbroken line, where every point represents a moment in time or a place in space. Imagine this line stretching infinitely, each point a whisper of existence, endlessly cascading into the horizon. This brings us to the concept of real numbers, which encompasses both rational and irrational numbers. Rational numbers can be expressed as fractions, while irrational numbers, such as the square root of 2 or pi, cannot be written as simple ratios. This distinction leads us to consider the density of the real number line. Between any two rational numbers, there exists an infinite number of irrational numbers. Can you envision this? Between any two seemingly ordinary fractions, there lies a hidden world of endless possibilities, each one as significant as the next. As we contemplate the richness of the continuum, we encounter the work of mathematicians like Cantor again, who introduced the concept of cardinality, the measure of the size of a set. Cardinality allows us to compare the sizes of infinite sets in a structured way. For instance, while both the set of natural numbers and the set of real numbers are infinite, their cardinalities differ. The natural numbers are countably infinite, while the real numbers are uncountably infinite. This distinction leads to a profound realization. Within the infinite, there exists a hierarchy, a layering that challenges our understanding of what it means to be infinite. Consider the implications of this hierarchy. If we think of infinity as a vast landscape with various terrains, some areas may be densely populated while others remain untouched, waiting to be explored. In this sense, Cantor's work opens a gateway to appreciating not just the vastness of infinity, but also its intricate structure. The mathematician Henry Poincaré once stated, "Mathematics is the art of giving the same name to different things," a notion that resonates with our exploration of infinity in its many forms. Moreover, the philosophical implications of continuity and the nature of infinity extend beyond mathematics. Take the realm of physics, where concepts such as space and time are often treated as continuous entities. Imagine standing at a crossroads in a vast, timeless expanse, where every choice branches out into infinite possibilities. This visualization invites us to reflect on the nature of our existence. Every moment, every decision, a point on a continuum that stretches beyond our understanding. As we delve deeper into the philosophical implications of infinity, we cannot ignore the existential reflections it evokes. The idea of the infinite challenges our perception of time, urging us to consider the past, present, and future as interconnected threads woven into the fabric of existence. The poet Rainer Maria Rilke beautifully articulated this sentiment, stating, "The only journey is the one within." In this light, the exploration of infinity becomes a deeply personal voyage, one that encourages us to seek meaning and connection in an endlessly complex universe. Infinity also finds a place in the realm of cosmology, where scientists ponder the shape and fate of the universe. If the universe is infinite, does it contain infinite realms, each with its own realities and possibilities? This thought invites us to reflect on the mysteries of our cosmos, trillions of galaxies, each with billions of stars, perhaps housing their own forms of life. It can be both exhilarating and humbling to consider that we occupy just a minuscule fraction of this vast expanse. As we contemplate the implications of infinity, we encounter key figures who have shaped our understanding in profound ways. The mathematician John von Neumann contributed significantly to set theory and the foundations of mathematics, furthering our grasp of infinite sets and their properties. His work exemplifies the interconnectedness of mathematics, philosophy, and physics, reminding us that the quest for knowledge transcends disciplinary boundaries. The exploration of infinity can also be a meditative practice. When we sit in silence and contemplate the vastness of existence, we can find solace in the idea that infinity encompasses all that we know and all that we have yet to discover. The boundaries of our understanding may seem daunting, yet within this boundlessness lies a sense of peace, a reminder that the universe is a grand symphony of interconnectedness. As we traverse this landscape of infinity, we must also acknowledge the questions that remain unanswered. What is the nature of the infinite? Is it a tangible reality or merely a construct of human thought? The philosopher Immanuel Kant suggested that our understanding of infinity is limited by our finite perceptions, leading us to wonder whether we can ever truly grasp its essence. In closing this segment of our exploration, we find ourselves standing at the threshold of infinity, gazing into the unknown with a sense of wonder and curiosity. Each step we take in this journey reveals new layers of understanding, guiding us toward a deeper appreciation of the infinite complexities that surround us. This journey does not have a definitive endpoint, but rather unfolds like an eternal horizon, beckoning us to continue our quest for knowledge and insight into the mysteries of existence. Chapter 2: The Infinite Number Line, Exploring Real Numbers. Imagine a straight, endless line, stretching infinitely in both directions. This line represents the number line, a foundational concept in mathematics that serves as a canvas upon which we paint our understanding of numbers. At its core, the number line is not just a tool for counting. It is a representation of all real numbers, a seamless continuum where every point corresponds to a unique value. As we explore this infinite expanse, we find ourselves contemplating its properties. Each point on the line holds significance, embodying both rational and irrational numbers. The beauty of the number line lies in its simplicity and complexity, a duality that invites us to ponder the very nature of numbers. It is a space where we can visualize the relationships between quantities, observe the distances between them, and understand how they interact. The density of real numbers is a particularly captivating property. Picture a tiny segment on this number line. No matter how small that segment may be, you can always find another real number nestled within it. This is known as the density property of real numbers. It suggests that between any two rational numbers, there exists an infinite number of other rational numbers, as well as an infinite number of irrational numbers. This endless possibility raises intriguing questions. How can something be both infinite and yet contained within a segment? Consider the concept of limits, which plays a crucial role in understanding this density. Limits allow us to approach a number infinitely closely, without ever necessarily reaching it. This aspect of limits is essential in calculus, where we study how functions behave as they approach specific points. The idea of approaching a value, of getting closer and closer without ever quite touching it, mirrors the nature of the number line itself. It serves as a reminder that our exploration of numbers is as much about the journey as it is about the destination. As we traverse this infinite landscape, we encounter rational numbers. These are numbers that can be expressed as a fraction of two integers. They might seem straightforward at first glance, but their richness is revealed when we consider their placement on the number line. For instance, the number 1/2 lies precisely between 0 and 1, while the number 3/3, which is equivalent to 1, occupies its rightful place. The order and structure of rational numbers create a familiar rhythm on the number line, offering a comforting sense of predictability. Yet the number line is not solely populated by rational numbers. Enter the realm of irrational numbers, which refuse to be confined to a simple fraction. These numbers, such as the square root of 2 or pi, cannot be expressed as a ratio of two integers. They weave through the fabric of the number line like elusive shadows, filling in the gaps left by their rational counterparts. Imagine standing at the edge of the number line, witnessing the dance of rational and irrational numbers. Each irrational number has a unique decimal representation that continues infinitely without repeating. The beauty of pi is that it captures the essence of circles, representing the ratio of a circle's circumference to its diameter. Its decimal expansion stretches endlessly, a reminder of the infinite nature of the universe. As we delve deeper into the concept of real numbers, we can visualize an infinite number of points on any line segment. Take a moment to imagine a segment from 0 to 1. At first glance, it may appear limited, yet between these two endpoints lies an uncountable infinity of real numbers. One could place 1/2, 1/3, 1/4, and so on, but there are also countless irrational numbers lurking within this segment, like the square root of 1/2 or the golden ratio. This leads us to the fascinating realization that not only are there infinite rational numbers, but also infinite irrational numbers in any given segment. In fact, the set of real numbers is uncountably infinite, a concept that has confounded and inspired mathematicians for centuries. The mathematician Georg Cantor, known for his groundbreaking work on set theory and infinity, stated, "The essence of mathematics is not to make simple things complicated, but to make complicated things simple." In this spirit, we unravel the intricate nature of real numbers, revealing how they coexist harmoniously on the number line. The interplay of rational and irrational numbers presents a tapestry of possibilities. Visualize this interplay as a symphony where each note represents a unique number. The rational numbers provide a steady beat, while the irrational numbers add depth and richness, creating a harmonious blend. This symphony, played out on the number line, invites us to listen closely, to hear the subtle nuances that lie within. As we ponder these infinite points, we can begin to appreciate the elegance of mathematical concepts like continuity and completeness. The real numbers are deemed complete because there are no gaps on the number line. Every single point is accounted for, whether it be rational or irrational. This completeness is fundamental to calculus, providing a framework for understanding limits and continuity, and it solidifies the number line as a powerful representation of our numerical world. Now, imagine taking a stroll along this infinite number line. With each step, you can choose to move to the left or right, exploring the vast expanse of numbers. You may find yourself lingering at the point representing 2, then meandering towards the left to reach -2, before finally gliding towards the right to discover the beauty of pi. Each movement reveals a new aspect of the number line, a fresh perspective on the infinite possibilities that lie ahead. As we continue our exploration, we begin to understand the significance of the number line in various fields of science and mathematics. It serves as a foundation for understanding more complex ideas, such as functions and equations. For instance, visualizing a quadratic function on the number line allows us to see the relationship between its roots and the x-axis, giving us insight into its behavior. Each point on the number line can be thought of as a potential solution to an equation, a solution waiting to be discovered. This idea connects the abstract world of numbers with practical applications, bridging the gap between theoretical concepts and real-world phenomena. Throughout history, thinkers like Descartes and Newton have harnessed the power of the number line to describe motion, change, and growth. The coordinate system, which extends the number line into 2 dimensions and beyond, allows us to graphically represent these relationships. By plotting points on a Cartesian plane, we can visualize equations, analyze data, and even model complex systems. As we stand at this intersection of theory and reality, we see how the number line becomes more than just a mathematical construct. It is a tool for understanding the universe, a way to map the relationships between quantities, and a means of expressing the complexities of existence itself. In this journey, we have only scratched the surface of the infinite possibilities that the number line offers. Each point, each number, invites us to explore further, to seek understanding, and to embrace the mysteries that lie within the infinite expanse of real numbers. We are reminded that, much like the number line, our own journeys are also filled with infinite potential, waiting to be discovered, understood, and shared. As we stand amidst the richness of rational and irrational numbers, we begin to appreciate the delicate balance of existence within the number line. This balance extends beyond mere classification and dives into the heart of mathematical exploration. The interplay between these numbers offers a glimpse into the infinite nature of mathematics itself, a realm where each inquiry leads to more questions, and every answer opens new avenues of thought. Imagine a point on the number line, perhaps the decimal representation of pi. As we dissect its digits, we uncover a world of complexity and beauty. The sequence unfolds endlessly, a reminder that some aspects of reality cannot be neatly packed into finite representations. This endlessness resonates with the notion of irrational numbers, which refuse to settle into a simple fraction. They embody a spirit of exploration, pushing us to consider the limits of our understanding. The concept of limits, integral to calculus, further enhances our understanding of the number line. When we approach a limit, we're not just inching closer to a number, we are engaging in a profound dialogue with the infinite. This dialogue reveals the subtle nuances of continuity and change. Picture a function that rises and falls, tracing the contours of the number line. As we zoom in on specific points along its path, we can observe how the function behaves, learning more about its character as we refine our approach. This leads us to a deeper contemplation of the density of real numbers. Between any 2 numbers, no matter how close they are, an infinite array of other numbers lies waiting. Imagine standing in a vast, open field. You spot 2 trees in the distance, yet as you walk towards them, you notice countless blades of grass, each one a number in its own right, filling the space between. This visualization captures the essence of density, showcasing how even the most finite-seeming segments of the number line are brimming with infinite potential. Rational numbers, while elegant in their simplicity, are but one part of this infinite spectrum. They provide a comforting familiarity, allowing us to express fractions and ratios that are easily comprehensible. Nevertheless, it is the irrational numbers that spark intrigue. Consider the golden ratio, often found in nature and art, a number that embodies beauty and harmony. Its decimal representation, like pi, is non-repeating and infinite, symbolizing the interconnectedness of mathematics with the world around us. The beauty of irrational numbers can be appreciated through their geometric representations as well. Picture a square with sides of length 1. The diagonal stretches across, measuring the square root of 2. This diagonal cannot be expressed as a fraction of integers, illustrating the mysterious nature of irrationality. Each irrational number lends a unique shape to our understanding of the number line, filling in gaps with their infinite complexity. As we explore further, we find ourselves drawn to the concept of uncountable infinity. The realization that there are different sizes of infinity is staggering. While rational numbers can be matched one-to-one with the integers, irrational numbers cannot. This distinction was brought to light by Cantor, who famously demonstrated that the set of all real numbers is uncountably infinite. Imagine trying to list all the points on the number line. No matter how diligently you work, you will never capture them all. This uncountable nature of the real numbers accentuates their richness and depth. Consider the number line as a vast ocean, with rational numbers floating like islands, distinct and identifiable. However, the deeper waters beneath are teeming with an uncountable variety of irrational numbers, swirling and intertwining in a beautiful chaos. This imagery invites us to dive deeper, to embrace the complexity rather than shy away from it. As we reflect on these ideas, we can appreciate how the number line serves not just as a mathematical tool, but as a philosophical canvas. It challenges us to think about concepts larger than ourselves. How do we understand infinity in our daily lives? How do we relate to the idea of continuity and change within our own experiences? The number line, in all its infinite glory, prompts us to ponder our place within the vast expanse of existence. In the world of science, the implications of the number line extend into physics and engineering. It allows us to quantify change, describe motion, and analyze patterns. The linear equations we use to model real-world phenomena find their roots in the relationships established by the number line. Each point on this line can represent a state of a system, a moment in time, or a specific measurement. Yet, the journey does not end here. As we continue to explore the properties of real numbers, we must also confront the challenges they present. The concept of irrationality may bewilder some, raising questions about the very nature of mathematical truth. Are all truths quantifiable? Can we ever fully grasp the infinite? These inquiries echo throughout the historical landscape of mathematics, inspiring thinkers to seek understanding in the face of uncertainty. The number line is not merely a representation of numbers. It is a profound symbol of our quest for knowledge. Each point, each infinitesimal segment, offers an invitation to explore the mysteries of existence. Just as mathematicians and philosophers throughout history have marveled at the infinite, we too can find solace in the vastness of the number line. Imagine, if you will, a quiet evening spent contemplating the stars. Each twinkle represents a point in the infinite cosmos, much like the numbers on our number line. The vastness around us mirrors the boundless possibilities that lie within mathematics. It encourages us to dream, to explore, and to delve into the unknown. As we reflect on the journey so far, we can appreciate how the number line serves as a bridge between abstract thought and tangible reality. It is a reminder that while numbers can be complex and elusive, they also possess a certain grace, reflecting the beauty of the universe. Each exploration along this line leads us to new vistas, new understandings, and an ever-deepening appreciation for the infinite. Now, as we prepare to continue our expedition into the realm of real numbers, let us carry with us the understanding that within this infinite expanse lies the potential for discovery, wisdom, and connection to the world around us. The number line is our guide, inviting us to journey forth with open hearts and curious minds, eager to uncover the secrets that await. Chapter 3: Cantor's Revolution, Comparing Infinities. Cantor emerged during a time when the concept of infinity was still shrouded in mystery and skepticism. His groundbreaking work on set theory not only transformed mathematics, but also sparked profound philosophical debates that continue to resonate today. Cantor, a German mathematician, introduced ideas that challenged the very fabric of mathematical thought, allowing us to see infinity not as a single entity, but as a vast landscape with its own structure and hierarchy. Imagine a world where infinity is not merely an abstract concept, but a place filled with different types of infinities, each with its own unique characteristics. Cantor's work laid the foundation for this notion, opening our eyes to a universe where some infinities are indeed larger than others. This revelation began with his exploration of cardinality, a term that denotes the size of a set. Cardinality allows us to compare the sizes of different sets, even when they are infinite. Before Cantor's insights, the notion of comparing infinities seemed absurd. How could one even fathom measuring something so boundless? Yet Cantor posed the question, what if we could quantify infinity? Through his work, he showed that not all infinite sets are created equal. Consider the set of natural numbers, which includes all the positive integers, 1, 2, 3, and so forth, extending endlessly. This set is infinite, but is it the only type of infinity? To uncover this, Cantor introduced a method for comparing infinite sets by establishing their cardinalities. He demonstrated that the set of all integers is countably infinite, meaning that its elements can be placed in a one-to-one correspondence with the natural numbers. Picture a never-ending line of integers, each one patiently waiting for its turn, lined up like soldiers ready for inspection. Now, let us shift our gaze to the set of real numbers, which includes all rational and irrational numbers. This set is uncountably infinite. Cantor's revolutionary insight revealed that there is no way to list all real numbers in a sequence that aligns them with the natural numbers. To illustrate this point, he presented what is now known as Cantor's diagonal argument. Imagine you attempt to list every single real number between 0 and 1. You might start with a decimal representation like 0.1, 0.2, and so on. But Cantor showed that for any list you create, you can always construct a new real number by altering the digits along the diagonal of your list. This new number would not be found in your original list, thus proving that the set of real numbers is indeed larger than the set of natural numbers. This groundbreaking revelation about cardinality has profound implications. It challenges our intuitive understanding of what it means for something to be infinite. Cantor's theorem tells us that while we can have a countably infinite set, such as the integers, there exists a larger infinity in the form of the real numbers. With this in mind, we must ask ourselves, what does it mean for something to be larger than infinity? Cantor's work did not just stop at demonstrating the existence of different sizes of infinity. It ignited a revolution in mathematics. His ideas faced significant resistance, particularly from contemporaries who found the notion of infinite sets unsettling. The mathematician Henri Poincaré famously remarked, "What is a set? What is a point? What is a number?" None of these concepts can be defined without introducing a certain amount of vagueness. Yet, despite the skepticism, Cantor persisted, driven by a passion for understanding the infinite. In a world that often seeks clear boundaries and definitions, Cantor's theories invite us to embrace ambiguity. They remind us that the universe, with all its complexities, is not confined to our limited perceptions. As we delve deeper into the implications of Cantor's work, we begin to understand the significance of his discoveries. His exploration of infinity challenges the way we think, not just in mathematics, but in life itself. Cantor's theorem also introduces us to the concept of power sets, which are sets containing all possible subsets of a given set. The power set of a set with a finite number of elements is always larger than the original set. For example, if we consider a set with two elements, say A and B, its power set will include the empty set, A, B, and the set itself, A, B. This simple observation has profound implications. When applied to infinite sets, we find that the power set of any infinite set is larger than the set itself. This revelation only deepens the wonder surrounding the nature of infinity. Imagine standing on the edge of an infinite ocean, where each wave corresponds to a different set of numbers. The waves crash upon the shore, and with each crest, we see reflections of Cantor's ideas. The infinite ocean is not uniform. It is filled with undulating layers of depth, each representing a different cardinality. The realization that there are more real numbers than integers is akin to discovering that the ocean floor holds treasures far beyond what we can perceive from the surface. As we reflect on Cantor's contributions, we encounter a profound realization. Infinity is not merely a concept to be understood, it is a journey to be experienced. Cantor's work invites us to explore the vastness of mathematical landscapes, urging us to question our assumptions and embrace the unknown. Infinity is not a number, Cantor once said, it is a concept. This perspective invites us to see beyond the numeric confines, allowing us to appreciate the elegance of mathematical relationships and the beauty of infinite possibilities. Cantor's revolution in set theory is not just a tale of numbers. It is a narrative of human curiosity and resilience. His determination to challenge the status quo and explore the uncharted territories of mathematics serves as an inspiring reminder of the power of inquiry. In a sense, Cantor embodies the spirit of a true explorer, venturing into realms where few dared to tread. His legacy continues to resonate, influencing contemporary mathematics and shaping the way we understand the infinite. Cantor's work has permeated various fields, from computer science to philosophy, where the exploration of infinity remains a topic of fascination. As we continue our journey through these mathematical landscapes, we find ourselves contemplating the implications of Cantor's discoveries on our understanding of the universe. What does it mean to compare infinities? How does this knowledge shape our perception of reality? These questions linger, inviting us to ponder the deeper connections between mathematics, philosophy, and the nature of existence itself. Through Cantor's lens, we learn that infinity is not a singular concept, but a diverse and intricate web of ideas. This understanding encourages us to appreciate the complexities of life, urging us to embrace uncertainty and ambiguity. In our search for meaning and understanding, we are reminded that the infinite possibilities before us extend far beyond what we can fathom. As we journey deeper into the world of infinity, we will explore the implications of Cantor's theorem further. The landscape of infinite sets beckons, inviting us to uncover the mysteries that lie within. Each step we take leads us closer to a greater understanding of the infinite, allowing us to appreciate the delicate interplay between mathematics and the universe at large. Cantor's exploration of infinite sets extends beyond mere comparisons of sizes. It invites us to contemplate how these concepts influence our understanding of mathematics and reality itself. The implications of his work reach into the very foundations of mathematics, reshaping our comprehension of numbers and their relationships. Consider the concept of transcendental numbers, which Cantor's discoveries help illuminate. Transcendental numbers, such as pi and e, defy representation as roots of any polynomial equation with rational coefficients. They lie beyond the rational realm, revealing another layer of complexity within the infinite set of real numbers. Imagine trying to pin down an elusive butterfly, only to find it fluttering just out of reach. These numbers, though part of the continuum, escape our grasp in a similarly enigmatic manner. Cantor's work invites us to ask, what does it mean to exist within an infinite continuum? If we think of the real numbers as a vast landscape, transcendental numbers are the hidden valleys and peaks, often overlooked yet integral to the whole. The realization that there are infinitely many transcendental numbers within the real numbers, just as there are infinitely many rational numbers, sparks a sense of wonder. It reminds us that even within familiar territories, there are depths yet to be explored. The richness of Cantor's contributions extends to the idea of the continuum hypothesis, which posits that there is no set whose cardinality is strictly between that of the integers and the real numbers. This hypothesis, though unproven, hints at the complexities that remain in the study of infinity. It encourages us to ponder the nature of mathematical truth and the limits of our understanding. Can we ever fully grasp the infinite? Or is our quest to comprehend it a journey without a final destination? As we reflect on Cantor's legacy, we find inspiration in his relentless pursuit of knowledge. He once stated, "The essence of mathematics is not to make simple things complicated, but to make complicated things simple." This philosophy resonates deeply within the realm of infinity, where the seemingly unfathomable becomes accessible through careful exploration and innovative thought. Cantor's ability to distill complex ideas into comprehensible forms is a testament to his genius. In contemplating Cantor's revolution, let us also consider the impact of his work on the field of topology, a branch of mathematics that studies the properties of space. Topology, emerging from Cantor's foundational ideas, explores how spaces can be transformed while preserving their essential characteristics. Imagine a rubber band that can stretch and twist without breaking. It embodies the essence of topological transformations. These ideas echo Cantor's insights, suggesting that even the most abstract concepts of size and infinity can have tangible implications in the physical world. The interplay between set theory and topology invites us to consider the broader implications of Cantor's work. We can imagine a universe where the infinite is not just a mathematical abstraction, but a guiding principle shaping the very fabric of reality. How do these ideas influence our understanding of space, time, and existence? The answers may elude us, but the questions inspire further inquiry, urging us to explore the confluences of mathematics and the universe. As we navigate through these profound concepts, we might find solace in the understanding that the quest for knowledge is not a solitary endeavor. Cantor's journey was shaped by the dialogues and debates of his time, reminding us that the path of discovery is often illuminated by the collective efforts of many. The mathematician David Hilbert famously remarked, "We must know, we will know." This determination to seek knowledge resonates in every corner of mathematics and beyond, uniting those who dare to question and explore. Cantor's work stands as a monumental pillar in the realm of mathematics, reshaping our perception of infinity and its many facets. His legacy continues to inspire mathematicians, philosophers, and thinkers across disciplines, echoing through the ages as we grapple with the mysteries of existence. As we delve deeper into the implications of Cantor's theorem, we are drawn to the profound realization that understanding infinity is not merely an academic exercise. It is an invitation to expand our horizons. The infinite beckons us to embrace the unknown, to revel in the complexity of existence, and to find beauty in the vast expanse of possibilities that lie ahead. In the quiet moments of reflection, we may find ourselves pondering the vastness of the cosmos, where the infinite intertwines with the finite, and the known meets the unknown. What does the universe reveal to us through the lens of infinity? How do the patterns of nature echo the mathematical relationships that Cantor so passionately explored? These questions linger in the air, inviting us to continue our journey into the infinite, where each step reveals a new layer of understanding, waiting to be uncovered. The exploration of infinity is not a destination, but a continuous voyage, rich with discoveries that transcend the boundaries of traditional thought. Each revelation leads us to question our assumptions, to expand our understanding, and to appreciate the intricate beauty of the infinite landscape that surrounds us. As we carry on with this exploration, we uncover the interconnectedness of concepts, where mathematics, philosophy, and the cosmos converge, inviting us to embrace the wonder of infinity itself. Chapter 4: Infinity in Calculus, Limits and Beyond. Infinity unfolds in calculus much like a gentle river, winding through the valleys of limits and continuity. At its essence, infinity serves as a backdrop against which the behavior of functions can be explored. To understand this interplay, we must first grasp the role of limits. Imagine standing on the edge of a cliff, peering down into the vastness below. The limit acts as a bridge, connecting the finite world to the infinite. It tells us how a function behaves as it approaches a certain point, which could be a specific value or infinity itself. Visualize a simple function like one that describes a curve. As you trace the path of the curve, you might notice that as the input value climbs higher and higher, the output approaches a specific height, yet never quite reaches it. This is the essence of limits. They allow us to quantify the behavior of functions at points that might otherwise be elusive. In this way, infinity is not merely an abstract idea, but a practical tool that enables us to understand continuity. A function is considered continuous when there are no sudden jumps or breaks, allowing us to move fluidly from one point to another. As the great mathematician Augustin Louis Cauchy once stated, mathematics is a language that describes the world. As we delve deeper into the realms of calculus, we encounter the concept of asymptotes, those invisible lines that guide the behavior of curves. Picture a graph where a function approaches a straight line but never quite touches it. This line is an asymptote, representing a boundary that the function nears infinitely. There are horizontal asymptotes, where the function approaches a specific value as the inputs grow large, and vertical asymptotes, where the function shoots off to infinity as it nears certain x values. Why do we find these asymptotes significant? They help us comprehend the limits of functions in more nuanced ways. For instance, consider the rational function that depicts a hyperbola. As we approach the vertical asymptote, the function can either ascend toward positive infinity or descend toward negative infinity, depending on the direction from which we approach. This behavior reveals how infinity manifests not just as a distant concept, but as a dynamic force that shapes the behavior of functions in the present moment. Moving forward, we encounter the fascinating world of infinite series, where the notion of summing an infinite number of terms comes into play. Imagine a sequence of numbers, each one getting smaller and smaller, as if they were leaves gently falling from a tree, one after another. We can ask ourselves, what happens if we keep adding these numbers forever? This question leads us to the concepts of convergence and divergence. A series converges when the sum approaches a finite limit, even as we continue to add more and more terms. Picture a winding staircase that leads up to a cozy attic. Each step takes you closer to a destination, and even though you could climb endlessly, the height you reach is finite. Conversely, a series diverges when the sum grows larger and larger without bound. Imagine a balloon being filled with air. No matter how much air you introduce, if you keep inflating it, there comes a point where it can't hold anymore and it bursts. The beauty of infinite series lies in their applications. One of the most notable examples is the geometric series, which converges under specific conditions. Consider a series where each term is half of the previous term. As you continue this process, the sum approaches 2, regardless of how many terms you add. This principle underlines the idea that infinity can yield tangible results, even while remaining elusive. Then we can reflect on the work of mathematicians like Leonhard Euler, who boldly explored infinite series. Euler once remarked, "Mathematics is the queen of the sciences." His contributions, particularly in the realm of series, transformed our understanding of the infinite. He demonstrated how complex functions could be represented as infinite series, paving the way for breakthroughs in calculus and analysis. As we explore convergence and divergence, we encounter the ratio test and the root test, tools that help us determine the behavior of series. Picture an ancient sailor navigating uncharted waters, using the stars to guide his course. Just as sailors relied on celestial navigation, mathematicians employ these tests to discern the fate of series. With each evaluation, they can predict whether a series will converge to a specific value or diverge into the vast unknown. The applications of infinity in calculus problems are as varied as the stars in the night sky. Engineers, physicists, and economists all rely on these principles to model real-world phenomena. Picture a bridge being designed to span a vast chasm. Engineers use calculus to ensure that the load will be distributed evenly, calculating the limits of the materials used. Similarly, physicists apply concepts of infinity when dealing with forces and motion. As they examine the behavior of objects approaching light speed or the gravitational pull of massive celestial bodies. In finance, the concept of present value relies on the principles of infinite series. Imagine an investor pondering the future returns of an investment. By summing the expected cash flows, discounted back to the present, they can determine the value of their investment today, even as those cash flows extend infinitely into the future. This practical application illustrates how infinity is not just an abstract notion, but a vital component of our everyday decision-making. As we reflect upon the tapestry of calculus, we see the profound integration of infinity within its framework. From the limits that guide our understanding of continuity to the series that allow us to explore the infinite sum of parts, each aspect unfolds a new layer of complexity and beauty. It is a journey that beckons us to look deeper, to imagine the infinite possibilities within our grasp. Consider, for a moment, the vastness of the universe and how it mirrors the infinite landscapes of calculus. Just as astronomers peer into the cosmos, searching for patterns and truths among the stars, mathematicians delve into the realm of infinity, seeking to unravel its mysteries. In this exploration, we find ourselves at the intersection of art and science, where the beauty of mathematics becomes a soothing balm for the restless mind. As we contemplate the nature of infinity within calculus, let us embrace the calm and serene aspects of this journey. Each concept we encounter, from limits to series, invites us to slow down and reflect on the grandeur of the universe around us. Infinity, in its essence, reminds us that there is always more to discover, more to learn, and more to appreciate in the world of mathematics and beyond. Imagine the thrill of standing at the edge of a cliff, gazing out at a vast horizon where the sky meets the sea. This image evokes the infinite potential of calculus as we delve into the applications of infinity in problem solving. The principles of calculus, intertwined with the notion of limits and continuity, allow us to tackle real-world challenges with confidence and precision. One key application of infinity arises in the realm of physics, particularly when analyzing motion. Picture a car accelerating down a highway. As it speeds up, we can observe its velocity at every moment, but what happens as it approaches the speed of light? According to Einstein's theory of relativity, as an object approaches this ultimate speed limit, its mass increases, and it requires more and more energy to continue accelerating. Here, infinity manifests in a tangible manner, illustrating the limits of our physical universe. It prompts us to consider the very fabric of reality, reminding us that there is a threshold we cannot cross. In engineering, these principles guide the design of structures meant to withstand immense forces. Imagine the construction of a skyscraper that pushes the boundaries of height. Engineers must calculate the limits of materials, ensuring that the building can support its weight and withstand external pressures, like wind and earthquakes. Infinite series come into play as they help model and predict the behavior of structures under various conditions. The interplay of calculus and engineering showcases how infinity provides a framework for understanding complex systems, allowing us to create resilient designs that stand the test of time. Moreover, the world of economics demonstrates another fascinating application of infinite concepts. Think of a business contemplating an investment that promises returns over an indefinite period. The notion of present value becomes crucial here. By summing the expected future cash flows and discounting them back to their present value, investors can make informed decisions. This process underscores how infinity is not just a mathematical abstraction, but a vital component in assessing the viability of financial ventures. As we move through these applications, we encounter the concept of optimization, a cornerstone of calculus that seeks to find the best solution among a set of choices. Imagine a farmer looking to maximize the yield of a crop. By applying calculus, the farmer can model the relationship between variables such as fertilizer usage, water, and sunlight exposure. Here, limits and derivatives come together, guiding the farmer to the optimal amount of resources needed for maximum growth. This journey toward optimization exemplifies the practical implications of infinity in decision-making processes. In the field of biology, the principles of calculus can illuminate complex systems, such as population dynamics. Picture a thriving ecosystem where species interact in intricate ways. As a population grows, it can reach carrying capacity, the maximum number of individuals an environment can sustain. Calculus helps model these changes over time, taking into account factors such as birth rates, death rates, and environmental constraints. Infinity plays a role here, reminding us that populations can fluctuate, sometimes experiencing exponential growth before hitting a limit imposed by their surroundings. As we explore these varied applications, we recognize that infinity in calculus is not merely a theoretical concept, but a tool that empowers us to understand and influence the world around us. It invites us to contemplate the delicate balance of forces at play in nature and human endeavors. Through this lens, we can appreciate the beauty of mathematics as it weaves through diverse fields. Let us also reflect on the remarkable individuals who have shaped our understanding of infinity and its applications. The legacy of Isaac Newton and Gottfried Wilhelm Leibniz, who independently developed calculus, stands as a testament to human ingenuity. Their work opened new avenues for exploring change and motion, laying the groundwork for countless advancements. As Newton famously stated, "If I have seen further, it is by standing on the shoulders of giants." This sentiment encapsulates the collaborative spirit of mathematics, where each discovery builds upon the last. In our contemplation of these concepts, we invite ourselves to imagine the infinite possibilities that lie ahead. What new discoveries await us in the realms of science, engineering, and beyond? The beauty of calculus lies in its ability to adapt and evolve, embracing new challenges that arise as our understanding of the universe expands. Infinity, in this context, becomes a source of inspiration, urging us to delve deeper into the unknown. As we continue this journey through the world of calculus, let us carry forward a sense of curiosity and wonder. Each new concept we encounter invites us to pause and reflect, to consider the profound implications of infinity in our lives. It is a reminder that, much like the cosmos above, the realms of mathematics and science are vast and full of potential, urging us to explore their depths with open hearts and minds. With each passing moment, we realize that the exploration of infinity is not merely an academic exercise. It is a journey of discovery that aligns with the very essence of what it means to be human. It beckons us to embrace the unknown and to seek out the intricate connections between mathematics and the world around us. In this way, we can appreciate calculus not just as a set of rules and formulas, but as a living, breathing entity that continues to shape our understanding of existence. Chapter 5: Infinity in Geometry, Shapes Without Bound. Imagine standing in a vast, open space where the horizon stretches infinitely in every direction. This is the realm of geometry, where lines and planes extend without end, inviting us to contemplate the nature of infinity. A line, when drawn, is an abstraction that seems simple yet embodies the concept of infinity itself. It has no width, no boundaries, and continues endlessly. Picture a single point on this line, a mere dot, yet it serves as a reference for all other points. Every point exists within the infinite expanse of this line. When we explore a plane, we encounter an even broader canvas. A plane is a flat surface that extends infinitely, much like the sky above us, stretching outward in every direction. Think of it as an infinite sheet of paper where you can draw countless lines and shapes, each representing a different aspect of reality. The beauty of geometry lies in its ability to represent the infinite through simple yet profound figures. Now, let us delve into the world of fractals, a captivating intersection of geometry and infinity. Fractals are geometric figures that repeat their patterns at every scale. They are self-similar, appearing the same whether viewed from afar or up close. This concept of self-similarity raises a fascinating question. How can a shape be both infinitely complex and utterly simple at the same time? Consider the Mandelbrot set, one of the most famous examples of a fractal. As you zoom in on its intricate boundary, the same patterns emerge, revealing smaller versions of the entire set. This mesmerizing quality exemplifies the idea of infinity within geometry, as the detail never ceases, no matter how much one magnifies it. Fractals can be found throughout nature, from the branching of trees to the formations of coastlines and clouds. They remind us that infinity isn't just a theoretical concept. It is woven into the very fabric of our world. In an infinite geometric space, dimensions multiply and expand without limit. Imagine a line as the first dimension, a plane as the second, and then picture a three-dimensional space, like our familiar world filled with height, width, and depth. But what if we venture beyond these three dimensions? The concept of infinite dimensions opens up a universe of possibilities. Take, for instance, the concept of Hilbert space, an infinite dimensional space that underpins various fields, including quantum mechanics. In this space, each point represents a possible state of a quantum system. It is a realm where traditional notions of geometry begin to blur, and the infinite unfolds in ways we can only begin to understand. Think about the implications of having an infinite number of dimensions. How would that change our perception of reality? In the realm of mathematics, there are extraordinary individuals who have contributed to our understanding of these infinite dimensions. One such figure is David Hilbert, a mathematician whose work revolutionized the field. He famously stated, "We must know, we will know." This determination to explore the unknown has driven countless mathematicians and scientists to investigate the infinite landscapes of geometry. As we consider the practical applications of infinite geometry, we find that its influence extends far beyond theoretical musings. Fractals, for instance, have been employed in computer graphics to create lifelike images that mimic the complexities of nature. The patterns found in fractals allow for realistic modeling of landscapes, clouds, and even human anatomy. In architecture, the principles of infinite geometry inspire designs that resonate with natural forms. The Sagrada Familia in Barcelona, designed by Antoni Gaudí, is a stunning example of how geometric principles can merge with artistic vision. Its intricate facades and towering spires reflect the self-similar patterns found in nature, bridging the gap between mathematics and beauty. In medicine, fractals help in understanding complex structures within the human body. The branching patterns of blood vessels or the structure of lungs can be analyzed through the lens of fractal geometry, offering insights into their function and efficiency. This understanding can lead to advancements in medical imaging and treatment techniques. The infinite also plays a crucial role in data science and artificial intelligence. Algorithms that rely on fractal geometry enable the processing of vast amounts of information, allowing us to recognize patterns and make predictions. In a world where data flows like a river, understanding the infinite nature of these patterns becomes essential for innovation. As we walk through this infinite landscape of geometry, we are reminded of the interconnectedness of all things. Each line, each plane, and each fractal reveals a deeper truth about the universe. They invite us to consider not just the shapes that surround us, but the infinite possibilities that exist within them. What lies beyond the familiar shapes we see? The answer may be as expansive as the cosmos itself, where dimensions intertwine and infinite forms emerge. The journey through this vast terrain is both illuminating and humbling, urging us to seek understanding while embracing the mysteries that remain. In this realm, we find that infinity is not merely a concept, but a fundamental aspect of existence. It shapes our understanding of the universe, guiding us through the complexities of both mathematics and nature. The exploration of infinite geometry is a testament to our quest for knowledge, a journey that invites us to dream and discover. Imagine standing before an infinite expanse, where the shapes and forms beckon you to explore further. Each line and each curve tells a story, revealing the beauty of a world that stretches beyond the limits of our imagination. It is an invitation to witness the unfolding of infinity, where the shapes without bound lead us into the heart of understanding itself. Fractals embody the essence of nature's complexity, presenting a realm where simplicity and intricacy coexist seamlessly. Each fractal, with its repeating patterns, invites us to ponder the very structure of reality itself. Consider the coastlines of our planet, which appear jagged and intricate when viewed from afar. Yet, as we draw closer, we find that this complexity is merely a manifestation of self-similar patterns that emerge at various scales. This phenomenon prompts us to ask, how does such complexity arise from a simple rule? The answer lies in the iterative processes that define fractals. Take the Sierpinski triangle, for instance. Starting with an equilateral triangle, one removes the upside-down triangle from its center, then repeats this process on the remaining smaller triangles. As we continue this iteration infinitely, the resulting structure reveals an intricate pattern that is both beautiful and mathematically profound. This is the heart of fractals. They are not merely shapes, but a language of patterns that echo through the natural world, from the branching of trees to the shapes of mountain ranges. Fractals also lead us to the intriguing concept of infinite dimensions. When we think of dimensions, we often limit ourselves to the familiar three: length, width, and height. However, beyond these, there exists a universe of infinite dimensions, which can be visualized through the lens of mathematics. Imagine a space where each point exists not just in 3 dimensions, but across an unbounded expanse of possibilities. This concept can be unsettling yet exhilarating, as it challenges our perceptions of space and reality. In mathematics, the notion of infinite dimensional spaces can be illustrated through the concept of function spaces. Each function can be viewed as a point in an infinite dimensional space, where the dimensions correspond to the coefficients of a polynomial or the values at each point on a curve. One can picture this as an ocean of functions, each unique yet belonging to the greater body of mathematical reality. The implications of this are profound. It means that the solutions to complex problems may reside in dimensions beyond our immediate grasp, waiting to be uncovered through exploration and inquiry. One of the notable figures in this domain is John von Neumann, a pioneering mathematician and physicist who contributed significantly to the understanding of infinite dimensional spaces. He once remarked, "There are no secrets in mathematics." This statement reflects his belief in the power of mathematical exploration, a sentiment that resonates deeply within the realm of infinite geometry. By delving into these higher dimensions, we can uncover new truths that expand our understanding of the universe. As we transition to the real-world applications of infinite geometry, we find ourselves in a landscape rich with innovation and discovery. The principles of fractals and infinite dimensions are not confined to theoretical mathematics. They have practical implications that touch various fields. In technology, fractal algorithms are used in image compression, allowing for efficient storage and transmission of data. By exploiting the self-similar patterns inherent in images, computers can compress files without significant loss of quality. Imagine a beautiful landscape captured in a photograph. Through the lens of fractal geometry, that image can be encoded in a way that preserves its essence while reducing its size. In telecommunications, fractals play a crucial role in antenna design. Fractal antennas can operate over a wide range of frequencies, thanks to their unique geometric properties. This adaptability is akin to a tree's branches, which can expand and contract as needed, ensuring that communication signals can reach their destinations without interference. Furthermore, the principles of infinite dimensions find their way into the realm of artificial intelligence and machine learning. Algorithms that leverage infinite dimensional spaces can enhance pattern recognition, enabling machines to learn from vast datasets with remarkable efficiency. This capability allows for advancements in numerous applications, from facial recognition to natural language processing, reshaping our interactions with technology. In the field of biology, the applications of fractals extend into understanding complex systems. The structures of biological organisms, from the branching patterns of neurons to the intricate networks of blood vessels, exhibit fractal properties. By studying these patterns, scientists gain insights into how organisms develop and function. It is fascinating to consider how the same mathematical principles that govern fractals also underpin the very fabric of life itself. As we traverse the landscape of infinite geometry, we are reminded that the exploration of these concepts is a journey without end. Each discovery opens new avenues for inquiry, inviting us to question and learn. What other secrets lie hidden within the folds of infinite dimensions and fractals? The quest for understanding inspires a sense of wonder, urging us to delve deeper into the mysteries of geometry and its profound implications. In this journey through the infinite, we encounter the beauty of shapes without bound, each one a testament to the complexity and interconnectedness of our universe. The lines and planes that stretch infinitely remind us of the potential that lies within the abstract, while the fractals reveal the underlying unity of nature's designs. The exploration of infinite geometry is not merely an academic pursuit. It is a reflection of our innate desire to comprehend the world around us and our place within it. Imagine a world where every curve and angle tells a story, where the infinite shapes invite us to explore their depths. This is the essence of geometry, a dance of ideas that unfolds across the dimensions, offering a glimpse into the infinite possibilities that await us. As we continue our journey, let us remain open to the wonders that lie ahead, embracing the infinite with curiosity and reverence. Chapter 6: The Paradoxes of Infinity, Mind-Bending Concepts. Imagine a grand hotel with an infinite number of rooms, all occupied. This is Hilbert's Hotel, a thought experiment that illustrates the peculiarities of infinity. At first glance, it may seem impossible for a fully booked hotel to accommodate more guests. Yet, by simply shifting each current guest from room N to room N+1, the hotel can welcome an infinite number of new arrivals. The paradox lies in the realization that infinity can be manipulated in ways that defy our everyday experiences. The hotel, with its endless corridors and rooms, represents not just a physical space, but a gateway into the strange realm of infinite possibilities. As we consider Hilbert's Hotel, we are compelled to ponder deeper questions about the nature of infinity. What does it mean for something to be infinite? Can we truly comprehend a quantity that has no bounds? Such inquiries echo the ideas presented in previous chapters about the number line and Cantor's insights into the hierarchy of infinities. Infinity is not merely a concept of more, but rather a profound exploration of existence itself. Now let us turn our attention to Zeno's paradoxes, which challenge our understanding of motion and division. One of the most famous is the paradox of Achilles and the tortoise. In this scenario, Achilles races a tortoise that has a head start. As he runs, he must first reach the point where the tortoise began. By the time he reaches that point, the tortoise has moved ahead. This process continues infinitely, suggesting that Achilles can never overtake the tortoise. The beauty of Zeno's paradoxes lies in their ability to provoke thought about the nature of space, time, and infinity. They force us to confront the limitations of our understanding and the assumptions we make about motion. Imagine standing on a track where each step forward is divided into smaller and smaller increments. Even as you take steps, the distance to your goal appears to stretch infinitely before you. Zeno's paradoxes reveal how our intuitive grasp of motion can falter when faced with the infinite. They challenge us to consider the implications of dividing a journey into an infinite number of parts. Can we ever truly reach our destination? Beyond the realm of mathematics, the problem of infinite regress emerges in philosophical discussions. This concept arises when a proposition requires justification from an infinite series of preceding propositions, leading to an endless chain of reasoning. Picture a house built upon a foundation made of other houses, each requiring its own foundation. The question then becomes, where does it end? Philosophers have grappled with the implications of infinite regress for centuries. Some argue that it undermines the pursuit of knowledge, while others suggest that it invites deeper exploration into the nature of existence. The challenge lies in the desire for ultimate explanations. Do we need a final answer, or can we embrace the uncertainty that accompanies infinite inquiry? As we reflect on these paradoxes, we begin to see how they challenge our understanding of infinity itself. They invite us to question our beliefs and assumptions, compelling us to explore the boundaries of human thought. Infinity, in its complexities, offers an open door to contemplation, where every question leads to further inquiry. Consider the implications of a universe where time itself may be infinite, stretching beyond the limits of our comprehension. What does it mean for our existence if the past and future are endless? This concept invites us to ponder our place within the cosmos and the nature of reality itself. The exploration of paradoxes related to infinity not only enriches our understanding of mathematics and philosophy, but also illuminates the wonder of human thought. We find ourselves at the intersection of knowledge and mystery, where the boundaries of understanding blur and infinite possibilities unfold. Every paradox serves as a reminder that while we seek clarity, the infinite often invites ambiguity. It challenges us to embrace the unknown and to find beauty in the complexities of our thoughts. As we journey through these mind-bending concepts, we come to appreciate that infinity is not simply a number or a concept. It is a vast landscape filled with questions and discoveries waiting to be explored. In the heart of this exploration lies the understanding that paradoxes are not mere puzzles to be solved, but gateways to deeper insights. They remind us that the quest for knowledge is an endless journey, one that expands our horizons and invites us to marvel at the mysteries of existence. As we contemplate the paradoxes of infinity, we find ourselves slipping into a state of wonder, where the mind can wander freely, contemplating the vastness of the universe and our place within it. The gentle ebb and flow of thought allows us to embrace the complexity of these ideas, inviting us to rest in the soothing embrace of the infinite. What might we discover if we allow ourselves to consider infinity not as a challenge to be solved, but as an experience to be lived? There is a tranquility in embracing the unknown, a calmness that washes over us as we realize that some questions may remain unanswered. In this acceptance, we find peace, allowing our minds to drift into the limitless expanse of possibility. As we delve into the heart of these paradoxes, we uncover the intricate dance between knowledge and mystery, revealing the profound beauty of infinity that surrounds us. Each paradox serves as a stepping stone, guiding us on our journey through the vast landscapes of thought. These explorations invite us to consider the many dimensions of existence, reminding us that in the realm of infinity, the journey is as significant as the destination. We are left with the comforting notion that even amid uncertainty, there is a sense of belonging. In the infinite embrace of the cosmos, we are all connected, each thought a thread in the grand tapestry of understanding. With each paradox, we are gently reminded of the limitless potential of the human mind, capable of reaching for the stars while grounded in the earth. We learn that infinity is not merely a construct of mathematics or philosophy, but a fundamental aspect of our existence, waiting to be explored with curiosity and wonder. As we float through this sea of ideas, let us cherish the beauty of our questions and the infinite possibilities that lie ahead. The paradoxes of infinity invite us to explore the depths of our curiosity, urging us to seek the profound in the ordinary and to embrace the mysteries that life presents. In this exploration, we discover not only the complexities of infinity, but also the soothing power of contemplation. The infinite invites us to pause, to breathe, and to reflect on the wonders of existence. Let us allow these thoughts to envelop us as we drift deeper into the understanding of infinity's paradoxes, exploring the mind-bending concepts that shape our reality. As we venture further, we will uncover the connections between these paradoxes and the nature of our own thoughts, exploring how they shape our understanding of the world and the universe around us. The journey is boundless, and with each step, we illuminate the darkness of uncertainty with the light of understanding. As we delve into the realm of infinite regress in philosophy, we encounter a profound inquiry that spirals into the depths of reasoning and existence. Imagine a series of dominoes, each one toppling over the next, ad infinitum. This image captures the essence of infinite regress, where each claim or proposition requires justification from a preceding claim, leading us down an endless path of inquiry. Philosophers have long wrestled with this concept, pondering its implications for knowledge and belief. For instance, the ancient Greek philosopher Aristotle acknowledged the challenge of infinite regress, suggesting that there must be a foundation upon which our knowledge is built. He proposed that some truths must be self-evident, serving as the bedrock of understanding. This idea prompts us to consider, can we ever arrive at a point of certainty, or are we destined to wander through an infinite landscape of questions? In a world that craves certainty, the problem of infinite regress can feel unsettling. We often seek definitive answers to our existential questions, yearning for a solid ground on which to stand. Yet, as we engage with this philosophical dilemma, we begin to realize that the pursuit of knowledge may not always lead to clear conclusions. Instead, it may invite us to embrace a more fluid understanding of existence, one that allows for ambiguity and uncertainty. Imagine a vast ocean of thought, where each wave represents a different idea, crashing against the shores of our understanding. The ebb and flow of these waves remind us that knowledge is not static, but rather a dynamic interplay of concepts. Infinite regress encourages us to surf this ocean, navigating the complexities of thought, rather than anchoring ourselves to a single perspective. Consider the words of one prominent philosopher who mused on the nature of infinite regress. "The only thing I know is that I know nothing." This sentiment encapsulates the journey of philosophical inquiry, where the recognition of our own limitations becomes a catalyst for deeper exploration. The act of questioning can be as enlightening as the answers we seek, drawing us into the rich tapestry of discourse that has shaped human thought for centuries. As we reflect on the implications of infinite regress, we are reminded that paradoxes serve to challenge our understanding of infinity itself. They push the boundaries of our thoughts, inviting us to question established beliefs and to explore the vastness of human experience. How do we reconcile the need for answers with the allure of the unknown? This is where the beauty of paradox lies. Within its folds, we find the potential for growth and discovery. In grappling with these concepts, we uncover a deeper understanding of infinity as a journey rather than a destination. It offers a space where inquiries can flourish, unfurling like petals of a flower in the warm sunlight. The quest for knowledge becomes an ever-expanding horizon, where each question leads to new pathways of thought, illuminating the shadows of uncertainty. As we continue to ponder these paradoxes, we see how they challenge not just our understanding of infinity, but also our perceptions of reality. The interplay between knowledge and mystery invites us to explore the very fabric of existence. Are we willing to embrace the questions that stretch beyond our current comprehension? In doing so, we may find solace in the infinite nature of inquiry itself. In the grand scheme of the universe, the paradoxes surrounding infinity remind us of our place within this vast cosmos. They encourage us to look beyond ourselves and to recognize the interconnectedness of all things. Each thought, each question, contributes to the ever-expanding narrative of existence, weaving a complex web of understanding that transcends the limitations of time and space. As we navigate this intricate landscape, we are invited to ponder the nature of our own experiences. How do our perceptions shape our understanding of infinity? Perhaps it is through the lens of our own lives that we begin to grasp the enormity of these concepts. Each moment is an opportunity to reflect, to question, and to embrace the infinite possibilities that lie within and around us. In this exploration, we find that the paradoxes of infinity are not mere intellectual exercises, but reflections of our own existence. They resonate with our deepest fears, hopes, and dreams, serving as a reminder that the human experience is intertwined with the infinite. As we confront these paradoxes, we open ourselves to a broader understanding of life, allowing the mysteries to unfold like a delicate flower blooming in the sunlight. With each revelation, we become more attuned to the subtle nuances of infinity, recognizing that it is not simply a mathematical abstraction, but a profound aspect of our journey through life. As we embrace the questions posed by paradoxes, we cultivate a sense of wonder and curiosity, inviting the mysteries of existence to guide us on our path. Thus, the exploration of infinity's paradoxes becomes a dance of thought, a gentle waltz through the corridors of knowledge, where each question leads us to new understandings. We learn to appreciate the beauty of uncertainty, finding comfort in the knowledge that our inquiries may never fully resolve, yet they enrich our lives in countless ways. In this infinite journey, we can find solace. The quest for understanding becomes a source of nourishment for the soul, a reminder that existence itself is a tapestry woven from the threads of our questions and reflections. As we peer into the depths of infinity, we discover not only the complexities of thought, but also the soothing embrace of contemplation, where the infinite invites us to explore the ever-unfolding narrative of life. Chapter 7: Infinity in Physics, the Cosmos and Beyond. The cosmos unfolds before us, vast and enigmatic, a canvas painted with the colors of infinity. When we ponder the universe, we are drawn into a realm where the concept of infinity reigns supreme. From the moment of the Big Bang, when the universe began its rapid expansion, we are confronted with questions that stretch the limits of our understanding. Is the universe finite or infinite? As we gaze into the night sky, filled with countless stars, we begin to grasp the intricacies of its boundless nature. In cosmology, infinity emerges in multifaceted ways. Imagine standing under a starry sky, each twinkle representing a galaxy, a cluster of stars, or even a supermassive black hole. The universe is not a static entity. It is alive, expanding, and evolving. During this expansion, the distances between galaxies stretch, leading to the realization that space itself is infinite. The observable universe, while limited by the speed of light and the age of the universe, hints at a far greater expanse beyond what we can see. It is like standing on a shore, peering out at an endless ocean, knowing that what lies beyond the horizon is beyond comprehension. Within this infinite cosmos, we encounter black holes, mysterious regions of space-time where gravity is so strong that nothing can escape. Picture a black hole as a cosmic vacuum, a singularity where the laws of physics as we know them break down. At its core lies the point of infinite density, a place where space and time cease to function as we understand them. As the renowned physicist Stephen Hawking remarked, black holes are not the end of the story, they are the beginning of a new chapter in our understanding of the universe. They represent the ultimate challenge, stretching our perceptions of infinity in both a mathematical and physical sense. Consider the event horizon of a black hole, the boundary beyond which nothing can return. As one approaches this threshold, time itself seems to slow down. To an external observer, an object falling into a black hole would appear to freeze at the event horizon, gradually fading away. This phenomenon brings forth a profound realization. In the realm of black holes, time and space are intertwined in a complex dance, leading us to question what we truly understand about reality. Can we ever fully comprehend a point where time itself becomes irrelevant? The implications of an infinite universe stretch beyond black holes and singularities, impacting our understanding of time and space. If the universe is indeed infinite, then time may also stretch infinitely into the past and the future. Imagine an eternal present, where every moment coexists with every other moment, unbound by linear progression. This concept challenges our perception of time as a simple linear flow. Instead, it suggests a cyclical nature of existence, a cosmic rhythm that resonates through eternity. As we explore this infinite expanse, we are reminded of the words of the visionary physicist Albert Einstein, who stated, "Time and space are modes by which we think, and not conditions in which we live." This perspective invites us to reconsider our relationship with time and space, urging us to step beyond our everyday experiences and embrace the infinite possibilities of the universe. In the realm of quantum mechanics, infinity takes on yet another dimension. Here, the infinitesimal becomes significant, illustrating that the universe is not just vast, but also composed of incredibly small, discrete units. Imagine particles behaving in ways that defy classical logic, where probabilities reign supreme and outcomes are inherently uncertain. In this microscopic world, infinity is not merely a concept. It is a reality that shapes the behavior of matter and energy at the most fundamental level. Consider the idea of superposition, where particles exist in multiple states simultaneously until measured. This phenomenon hints at a universe filled with infinite possibilities, where each choice branches out into a multitude of potential paths. It challenges our understanding of determinism and raises questions about the nature of reality itself. What does it mean for an object to exist in multiple states at once? Can we truly grasp the implications of an infinite array of possibilities? The notion of infinity in quantum mechanics also leads us to contemplate the nature of entanglement, where particles become intertwined in ways that transcend distance. Imagine two particles, separated by vast expanses of space, yet instantaneously influencing each other's states. This uncanny connection defies our conventional understanding of locality and suggests a deeper underlying reality. It invites us to ponder whether this interconnectedness hints at an infinite tapestry of existence, where every action resonates throughout the cosmos. As we immerse ourselves in these profound concepts, we begin to see the interplay between the infinite and the finite. The universe, with its cosmic wonders and unfathomable mysteries, invites us to consider our place within it. Are we simply observers in a grand cosmic theater, or do we play an active role in shaping the narrative of infinity? In the realm of physics, infinity serves as both a challenge and an inspiration. It beckons researchers and thinkers to push the boundaries of knowledge, to explore the depths of black holes, the intricacies of quantum mechanics, and the vastness of the cosmos. As we ponder these questions, we are reminded of the importance of curiosity and the human spirit's relentless pursuit of understanding. Imagine standing on the precipice of knowledge, gazing into the infinite depths of the universe. Each discovery, each insight, serves as a stepping stone toward a greater understanding of our existence. Infinity is not merely a number or a concept. It is a doorway to exploration, a catalyst for wonder, and an invitation to embrace the mysteries that lie beyond our comprehension. As we continue our journey through infinity, we find ourselves at the crossroads of science and philosophy. The questions we ask about the universe echo through time, resonating with the thoughts of those who came before us and inspiring future generations to explore the unknown. What lies beyond the edge of our understanding? What new horizons await us in the infinite cosmos? Our exploration of infinity in physics reveals a universe that is alive with possibility, beckoning us to delve deeper into its mysteries. The beauty of infinity lies not just in its vastness, but in its ability to inspire awe and ignite our imagination. As we traverse the realms of cosmology, black holes, and quantum mechanics, we are reminded that the quest for understanding is a journey without end, where every answer leads to new questions, and every discovery expands our horizons. In this infinite cosmos, we are not alone. We are part of a grand narrative that transcends time and space, woven into the very fabric of existence. The infinite invites us to dream, to question, and to explore, reminding us that the universe is a canvas waiting to be painted with the colors of discovery. The journey continues, and the infinite awaits. As we venture further into the concept of infinity within the cosmos, we encounter the awe-inspiring implications of an infinite universe on time and space. Envision a universe that has no boundaries, where time stretches infinitely in both directions. What does this mean for our understanding of existence? If time is infinite, can we truly grasp the enormity of the past and the future? Each moment may become an echo of countless others, resonating throughout eternity, challenging our linear perception. In this boundless realm, the very fabric of reality becomes interwoven with the essence of infinity. The notion that time is cyclical rather than linear invites us to reconsider our experiences. Imagine a world where the past is not behind us, but alongside us, weaving into the present and extending into the future. The ancient philosophical concept of eternal recurrence emerges, suggesting that every event will recur infinitely across time. This idea resonates with the thoughts of thinkers like Friedrich Nietzsche, who posed questions about the implications of living one's life over and over. Would our choices change, or would we find solace in the cyclical nature of existence? The idea of an infinite universe also ignites curiosity about the nature of space itself. Imagine galaxies existing in an unending expanse, each one a world of its own, teeming with stars, planets, and perhaps even life. This vision challenges the very essence of what we know about the universe. If space is infinite, then there are potentially infinite configurations of matter and energy, leading to the possibility of countless worlds like our own, each with its own unique narrative. The universe becomes a grand stage, filled with infinite stories waiting to unfold. As we meander through this vastness, we cannot overlook the profound implications of black holes and singularities. These enigmatic entities exist at the intersection of infinity and reality. Within a black hole lies a singularity, a point where density becomes infinite and the known laws of physics cease to apply. Picture this. Gravity becomes so intense that it distorts the very fabric of space-time, creating a region from which nothing can escape. This leads us to ponder the question, what lies beyond the event horizon? Is it merely a veil, a threshold that separates us from an unfathomable reality? Renowned physicist Kip Thorne, who contributed significantly to our understanding of black holes, suggested that these cosmic phenomena might hold the key to understanding the universe's most profound mysteries. He once remarked that black holes may not be the end of the universe, but rather gateways to various realms of existence. As we imagine the possibilities, we are drawn to the idea that black holes could serve as portals, connecting different regions of space-time, possibly even other universes. In the realm of quantum mechanics, infinity emerges yet again, but in a different guise. Here, we encounter infinitesimals, quantities so small that they defy our conventional understanding. Picture a world where particles exist in states that are not fixed, but rather oscillate between possibilities. This quantum dance leads us to the concept of wave functions, which describe the probabilities of a particle's position and momentum. The infinite nature of these probabilities invites us to consider the very essence of reality. What if our understanding of existence is limited by our perception? Imagine a universe where every decision creates a branching path, leading to infinite outcomes. This is the essence of the many worlds interpretation, which posits that every possible event creates a new universe. Each choice we make, no matter how small, could give rise to a parallel reality. This notion echoes the idea from earlier chapters about the density of real numbers, where between any 2 points lies an infinite continuum. In this quantum landscape, we find ourselves questioning the nature of causality and the interconnectedness of all things. Entanglement, another fascinating aspect of quantum mechanics, further complicates our understanding of infinity. Here, particles that have interacted become intertwined in such a way that the state of one particle instantaneously affects the state of another, regardless of the distance separating them. Imagine two particles light years apart, yet their fates are eternally linked. This phenomenon challenges our notions of locality and hints at a deeper interconnectedness woven into the fabric of the universe. Could it be that entanglement is a reflection of the infinite bonds that exist between all matter and energy? As we reflect on these profound ideas, we begin to appreciate the intricate dance between infinity and the finite. Infinity serves as both a challenge and a source of inspiration for scientists, philosophers, and dreamers alike. It invites us to push the boundaries of our understanding, urging us to explore the depths of the cosmos and the tiniest realms of quantum mechanics. Consider the journey of those who have dared to traverse this infinite landscape. Think of the early astronomers who gazed at the stars and began to fathom the vastness of the universe. Their curiosity laid the groundwork for modern cosmology, leading to breakthroughs that continue to shape our understanding of existence. Each discovery, each insight, serves as a testament to the human spirit's relentless quest for knowledge. In this infinite cosmos, we find ourselves not merely as observers, but as participants in a grand narrative that transcends time and space. The questions we pose about the universe resonate through the ages, inviting future generations to explore the unknown. What mysteries await us in the infinite depths of reality? What wonders lie beyond the horizon of our comprehension? As we contemplate the infinite, we are reminded that it is not just a concept to be understood, but a call to explore, to dream, and to reach for the stars. The universe, in all its complexity and beauty, beckons us to embrace the infinite possibilities that lie ahead. The journey continues, each step revealing new facets of existence, and the infinite awaits our discovery. Chapter 8: Infinity in Computing, the Limits of Technology. In the realm of computing, we find ourselves confronting the notion of infinity in ways that mirror the philosophical explorations of mathematics. As we peel back the layers of computational limits, we discover that the infinite is not merely an abstract idea, but a tangible challenge that engineers and programmers face daily. Understanding computational limits invites us to contemplate what can be achieved through technology and where the boundaries lie. Imagine a vast landscape of processes, each one representing a potential solution to a problem. Yet within this landscape, there are paths that lead to nowhere, known as infinite loops in programming. These loops arise when a set of instructions is executed repeatedly, often without a clear endpoint. Picture a hamster running tirelessly on its wheel, moving in circles but never reaching a destination. This phenomenon highlights a critical aspect of programming: the importance of defining clear termination points to ensure that processes can conclude. The elegance of computation lies in the ability to create systems that can process information in profound and complex ways. Yet, as we develop these systems, we must remain vigilant to the infinite possibilities that can emerge. What happens when a program is caught in an infinite loop? It consumes precious resources, ultimately leading to system failure or a crash. This is a reminder that while technology can perform remarkable feats, there are inherent limitations we must respect. As we explore further, we encounter the concept of Turing machines, a theoretical construct that has shaped our understanding of computable infinity. Imagine a simple machine that can read and write symbols on a tape, moving back and forth as it processes information. This machine serves as a model for understanding what it means for a function to be computable. The brilliance of Alan Turing's work lies in his ability to demonstrate that some problems are solvable, while others remain forever beyond our reach. Consider the implications of Turing's insights. If a problem can be expressed as an algorithm, then it is computable. However, not all mathematical questions can be resolved in this manner. Turing famously posed the halting problem, which asks whether it is possible to determine if a given program will eventually halt or continue to run indefinitely. This inquiry into the limits of computation reveals a profound truth. There are questions that elude even the most powerful machines. The idea of computable infinity raises fascinating questions about the algorithms we create and the data we process. Algorithms serve as the backbone of our technological advancements, guiding our devices in their quest to solve complex problems. They are carefully crafted sequences of instructions designed to efficiently manipulate data. Yet, as we embrace the infinite possibilities of algorithms, we must also confront the consequences of their limitations. Imagine an algorithm designed to sort an ever-expanding list of data. As the list grows, the time it takes to sort can escalate dramatically. This challenges our understanding of efficiency and performance. In many cases, algorithms can be optimized to handle larger datasets, but they are often still bound by the constraints of time and space. As we develop more sophisticated algorithms, we inch closer to mastering the infinite, yet we must acknowledge that there will always be boundaries to our computational power. Reflect on the legacy of pioneers like John von Neumann, who laid the foundations for modern computing. His work on algorithms and architectures reinforces the idea that while we strive for efficiency, we must also respect the intricacies of infinity. Von Neumann once remarked, "The science of today is the technology of tomorrow." This idea encapsulates our pursuit of knowledge and understanding as we harness the infinite to fuel innovation. The implications of infinity extend beyond theoretical constructs. They resonate in our everyday experiences with technology. As we interact with devices that seem to understand us, we witness the extraordinary capabilities enabled by algorithms. Yet, these systems are not infallible. They can become ensnared in loops of logic, echoing the challenges faced by early programmers who grappled with the nature of computation. As we reflect on the journey of computing, we are reminded of the importance of clarity in our algorithms. A well-defined process can navigate the complexities of infinity, guiding us toward solutions rather than entrapment. It invites us to consider how we can harness the power of technology while remaining cognizant of its limitations. In contemplating the interplay between infinity and computation, we begin to appreciate the delicate balance at play. The infinite nature of possibilities fuels our creativity, yet it also demands our caution. As we design algorithms, we must ask ourselves, how do we ensure that the paths we create lead to meaningful outcomes? How can we embrace the infinite while respecting the finite resources at our disposal? As we journey deeper into the world of algorithms and data processing, we come to understand the essential role of infinity in defining our computational landscape. It shapes the way we design systems, influences our understanding of efficiency, and ultimately guides our innovations. The challenge lies in managing the infinite within the finite constraints of our technology. Venture further and consider how data processing exemplifies the intersection of infinity and technology. In a world overflowing with information, the ability to analyze and derive insights from vast datasets has become paramount. The challenge of processing this data often invokes the concept of infinite possibilities. Each piece of data can be seen as a point in an infinite space, where patterns and connections await discovery. Imagine a data stream flowing like a river, carrying with it the potential for knowledge and understanding. Yet, this river can become turbulent and overwhelming if not managed properly. Algorithms must be designed to sift through this data, identifying trends and extracting meaningful insights. This process, akin to fishing in a vast ocean, requires precision and skill to navigate the boundless waters of information. The implications of infinity in data processing also prompt us to consider the ethical dimensions of our technological advancements. As we harness the power of algorithms to analyze data, we must remain vigilant about the potential for bias and misinterpretation. This awareness reflects a commitment to responsible innovation, ensuring that our pursuit of knowledge does not overlook the human elements embedded in the data we process. The interplay of infinity within computing serves as a reminder of the profound questions that arise when we push the boundaries of technology. As we strive to understand the nature of computation, we must continually reflect on the implications of our work. What does it mean to tap into the infinite? How can we ensure that our innovations serve humanity while respecting the limitations inherent in our systems? In this exploration of infinity in computing, we find ourselves at a crossroads where creativity meets responsibility. The infinite possibilities of technology beckon us to explore uncharted territories, yet they also compel us to tread thoughtfully. As we continue to build upon the foundations laid by visionaries in the field, we embrace the challenge of navigating the infinite while honoring the finite dimensions of our world. As we delve into the intricacies of algorithms and data processing, the notion of infinite possibilities reveals itself in fascinating ways. Algorithms, the very heartbeat of computation, guide our machines through a labyrinth of choices, but they must be crafted with precision to avoid the pitfalls of the infinite. Imagine an artist meticulously selecting colors from an endless palette, each choice capable of transforming the final masterpiece. Similarly, each decision made by an algorithm can lead to a multitude of outcomes, some fruitful and others leading to complexity without resolution. The beauty of algorithms lies in their ability to simplify the seemingly infinite chaos of data. Consider the process of searching for a specific piece of information within a vast ocean of data. Without algorithms, this task would be akin to finding a single grain of sand on a sprawling beach. Yet, with a well-designed search algorithm, we can navigate this infinite expanse efficiently, pinpointing the desired information with remarkable accuracy. However, the very act of processing data introduces another layer of complexity. As datasets grow in size and complexity, the challenge of managing time and space becomes increasingly pronounced. Imagine a library that expands infinitely, filled with every book ever written. While such a repository is a treasure trove of knowledge, the question arises: how do we organize and retrieve this information effectively? The answer lies in the algorithms that dictate how we access and manipulate data. One notable figure in this realm is Donald Knuth, a pioneer in computer science who emphasized that the art of programming is the art of organizing complexity. His work on algorithm analysis has profoundly influenced how we approach problem-solving in computing. Knuth's insights remind us that while we may strive to harness the infinite, we must also be mindful of the complexities that arise from our designs. As we reflect on the implications of infinity in data processing, we must also consider the ethical dimensions that accompany our technological advancements. The algorithms we create do not exist in a vacuum. They interact with the world around them. With the power to analyze vast amounts of data comes the responsibility to ensure that our conclusions are just and equitable. This requires an awareness of the biases that can inadvertently seep into our algorithms, leading to outcomes that may perpetuate inequality. Imagine a scenario where an algorithm is tasked with making decisions that affect individuals' lives, such as in hiring practices or loan approvals. If the underlying data contains biases, the algorithm may inadvertently reinforce those biases, leading to unfair treatment. Thus, the infinite possibilities of data processing compel us to scrutinize our algorithms, ensuring that they promote fairness and transparency. The intersection of infinity and technology invites us to reconsider how we define success in computing. Is it merely about achieving greater efficiency, or is it also about fostering ethical practices? As we harness the power of algorithms to interpret data, we must remain vigilant stewards of the information we process. As we continue to explore the limits of technology, the implications of infinity become ever more apparent. The complexity of algorithms and the vastness of data create a landscape rich with potential yet fraught with challenges. This duality compels us to ask ourselves, how can we push the boundaries of what is possible while remaining grounded in our ethical commitments? How do we navigate the infinite without losing sight of our humanity? The journey through the world of computation is not merely about mastering algorithms. It is about understanding the interplay between our creations and the world we inhabit. Each decision we make as programmers and engineers shapes the technological landscape, influencing how we interact with the infinite possibilities before us. As we advance towards more sophisticated systems, we see the emergence of machine learning, a domain that epitomizes the dance between infinity and computation. Imagine teaching a machine to learn from data, to adapt and improve over time, much like a child learning to walk. Machine learning algorithms thrive on vast data sets, extracting patterns and insights that were previously hidden. This capability opens the door to innovations that can transform industries and enhance our daily lives. Yet, as we embrace the power of machine learning, we must also recognize the limitations inherent in these systems. The complexity of the algorithms can lead to outcomes that are difficult to interpret, often referred to as the black box phenomenon. This unpredictability raises critical questions about accountability and transparency. How do we ensure that the decisions made by intelligent systems align with our values? The ongoing exploration of infinity in computing compels us to consider not only what is possible, but also what is responsible. As we harness the infinite potential of technology, we must remain mindful of the ethical implications of our work. The interplay of infinity and computation is not merely an academic pursuit. It is a call to action, urging us to build systems that reflect our shared aspirations for a just and equitable society. In this dynamic landscape, the challenge is to balance the infinite possibilities of technology with the finite realities of our world. As we innovate and explore, we must cultivate a mindset that embraces responsibility alongside creativity. The quest for knowledge and understanding should always be tempered by a commitment to ethical practices, ensuring that our advancements serve the greater good. Through this journey, we are reminded that while infinity may captivate our imaginations, it is our responsibility to navigate its complexities with care and intention. The infinite potential of computation is a gift, one that we must cherish and wield wisely. As we continue to push the boundaries of technology, let us do so with a spirit of inquiry and a dedication to creating a future that honors both the infinite and the finite. Chapter 9: The Philosophical Debate, Infinity's Nature. Throughout history, the concept of infinity has evolved through a rich tapestry of philosophical thought, intertwining the realms of mathematics, metaphysics, and existential inquiry. As we trace the historical perspectives on infinity, we begin in ancient Greece, where philosophers like Pythagoras and Aristotle grappled with the nature of the infinite. Pythagoras, who famously regarded numbers as the essence of all things, viewed infinity with a certain trepidation, suggesting that it was a concept best kept at bay, a realm of chaos. Aristotle, on the other hand, offered a more nuanced examination, distinguishing between potential infinity, something that can be endlessly divided, and actual infinity, an unbounded, completed totality. Fast forward to the Middle Ages, and we find a shift in the conversation. The works of theologians such as Augustine and Aquinas introduced a divine dimension to infinity. Augustine famously pondered, "What is time? If no one asks me, I know what it is. If I wish to explain it to someone who asks, I do not know." His reflections echo the elusive nature of infinity itself. Aquinas, in his theological explorations, emphasized that God embodies an actual infinity, possessing limitless wisdom and power, thus intertwining the divine with the infinite. As we journey into the Renaissance and Enlightenment periods, figures like Galileo and Descartes began to challenge the established views. Galileo famously posited that infinity is not merely a concept, but a reality, suggesting that there are different sizes of infinity. This assertion laid the groundwork for the debates that would later unfold in the mathematical realm. The question of actual versus potential infinity became a focal point, igniting discussions that resonate even today. The clash between actual and potential infinity emerged as a profound debate within philosophy. Actual infinity suggests a completed set, like the entirety of natural numbers, whereas potential infinity embodies an ongoing process, like counting towards infinity without ever reaching it. Imagine standing at the edge of a vast ocean, where the waves represent the potential to count endlessly, yet the horizon remains ever distant. This distinction raises tantalizing questions. Can we truly conceive of something as infinite in a completed sense? Or does infinity exist solely in our minds, a reflection of our aspirations and desires? In the realm of metaphysics and existentialism, infinity plays a pivotal role in shaping our understanding of existence. The existentialists, in particular, grappled with the implications of an infinite universe. Thinkers like Jean-Paul Sartre and Martin Heidegger explored how the infinite can evoke a sense of both freedom and despair. Sartre famously remarked, "Man is condemned to be free," suggesting that with the boundless possibilities of existence comes the weight of choice and responsibility. The infinite potential of human experience can be both liberating and overwhelming, prompting us to confront the fundamental questions of our existence. Contemporary philosophical discussions on infinity have further deepened our understanding. Modern philosophers have engaged with infinity through various lenses, from the implications of set theory to the paradoxes that arise within it. The work of philosophers like W.V.O. Quine and Hilary Putnam has encouraged a reevaluation of our ontological commitments regarding infinity. They challenge us to consider whether infinity is a metaphysical necessity or a mere conceptual tool. Consider the implications of Cantor's work on set theory, which expanded our understanding of infinity into a hierarchy of infinities. Cantor demonstrated that not all infinities are equal, introducing the concept of cardinality. This revelation invites us to imagine an infinite landscape populated by varying sizes of infinity, each with its own unique characteristics. How does this hierarchy of infinities influence our understanding of the universe's structure? Philosophers today continue to explore these questions, often drawing on the insights of mathematical discoveries. The intersection of mathematics and philosophy reveals a rich vein of inquiry. Infinity is no longer just a mathematical abstraction, it becomes a fundamental element of our worldview. The contemplation of infinity pushes us to ponder the nature of reality itself. Is the universe infinite? Are there infinite parallel realities existing alongside our own, each shaped by different choices and outcomes? The philosophical debate surrounding the nature of infinity remains vibrant and ongoing. As we navigate through the thoughts and theories of both historical and contemporary figures, we are reminded of the profound impact infinity has on our understanding of existence. This exploration of infinity is not merely an academic pursuit. It resonates with our lived experiences. The notion of the infinite serves as a mirror reflecting our deepest desires, fears, and aspirations. Just as the infinite cosmos invites us to question our place within it, the philosophical discourse on infinity encourages us to delve into the very essence of what it means to be human. As we stand at the precipice of these discussions, we may find ourselves wondering, what does it mean to confront something as vast and unfathomable as infinity? How does our understanding of infinity shape our perception of time, existence, and the universe itself? In this ongoing dialogue, we find a comforting reminder that the quest for understanding is as infinite as the concept itself. Each question leads to new realms of inquiry, inviting us to explore the boundless possibilities that lie ahead. Infinity, in all its complexity, remains a gateway to deeper understanding, urging us to ponder the mysteries of existence with both wonder and humility. As we navigate through the philosophical landscape of infinity, we encounter another layer of complexity, the interplay between infinity and the human experience. The concept of infinity often evokes existential reflections, prompting questions about our existence within a seemingly boundless universe. Imagine standing beneath a starry sky, each star a distant sun, each twinkle a reminder of the vastness that surrounds us. How do we reconcile our finite lives with the infinite expanse of the cosmos? Philosophers like Soren Kierkegaard and Friedrich Nietzsche have grappled with these questions, each offering unique insights into the relationship between human existence and the infinite. Kierkegaard articulated the tension between the finite self and the infinite possibilities that lie beyond, suggesting that true existence is found in the embrace of this tension. Nietzsche, with his proclamation of the eternal recurrence, invites us to consider the implications of living a life that could repeat infinitely. What choices would we make if we had to live our lives over and over again? This notion challenges us to reflect on the significance of our actions and the weight of our decisions. The implications of infinity extend into the realm of ethics as well. If we consider the infinite potential of human creativity and innovation, we must also confront the responsibilities that accompany such freedom. Philosophers like Peter Singer have explored the moral dimensions of our choices in an interconnected world. If our actions can ripple through the fabric of existence, influencing countless lives, how do we navigate our ethical obligations? The concept of infinity becomes a guiding principle, urging us to consider the long-term consequences of our decisions, not just for ourselves, but for future generations. As we delve deeper into contemporary discussions on infinity, we encounter the contributions of thinkers such as Elaine Badiou and Graham Harman. Badiou, in his exploration of the infinite in mathematics and philosophy, emphasizes the importance of events and the ways they shape our understanding of reality. He posits that events can create new infinities, thereby expanding the realm of possibilities. This perspective resonates with our earlier discussions on Cantor's hierarchy of infinities, where each mathematical discovery reveals new dimensions to the infinite. Harman, on the other hand, engages with the concept of infinity through the lens of object-oriented ontology. He argues that objects, whether they be physical or abstract, exist independently of human perception, and that their relationships can create an infinite web of connections. This perspective invites us to imagine a universe filled with diverse infinities, each interconnected yet distinct. How does this understanding of objects and infinity transform our perception of reality? It encourages us to see the world not as a static entity, but as a dynamic interplay of forces and relationships, ever expanding and evolving. The philosophical exploration of infinity does not shy away from paradoxes that challenge our intuition. For instance, consider the notion of an infinite timeline. If time is infinite, does that imply that every possible event has occurred or will occur? This leads to the intriguing idea of infinite possibilities, where every choice we make branches into countless potential futures. Yet, this also raises questions about determinism and free will. Are we free to choose our paths, or are we merely following a predetermined script written in the stars? In the field of metaphysics, the implications of infinity challenge our understanding of existence itself. Philosophers such as David Lewis have posited theories of modal realism, suggesting that all possible worlds are as real as our own. This perspective aligns with the notion of infinite parallel realities, where every decision creates a new branch in the tapestry of existence. Here, the idea of infinity becomes a gateway to exploring the nature of reality, prompting us to question the limits of our perception and understanding. As we reflect on these profound inquiries, we may find ourselves captivated by the beauty and complexity of infinity. It offers a lens through which we can examine not only the universe, but also the very essence of our humanity. The infinite invites us to dream, to question, and to explore the depths of our existence. What does it mean to engage with infinity in our daily lives? How can we harness the potential of infinite possibilities to enrich our experiences and foster deeper connections? In closing this section of our exploration, we acknowledge that the philosophical debate surrounding infinity is not merely an abstract exercise. It resonates deeply with our lived experiences, urging us to confront the mysteries of existence with both curiosity and reverence. As we continue our journey through the realms of infinity, we are reminded that each question we pose leads to new horizons of understanding, illuminating the path ahead with the promise of discovery. The conversation around infinity is as boundless as the concept itself, inviting us to embrace the unknown with open hearts and minds. As we traverse the philosophical landscape of infinity, we encounter another essential layer: the implications of infinity on ethics and morality. The concept of endlessness extends far beyond abstract discussions. It permeates our understanding of responsibility and choice in an interconnected world. Imagine standing before a vast web of connections, each thread representing the impact of our actions on others. How do we navigate this intricate tapestry of interactions, where every decision we make can resonate through time and space? The ethical dimensions of infinity compel us to consider the long-term consequences of our choices. Thinkers like Peter Singer advocate for a consequentialist approach, urging us to recognize that our actions can ripple outward, influencing lives in ways we may never fully comprehend. This perspective invites us to reflect on our obligations to others, especially in a world facing profound challenges. If we acknowledge the infinite potential for positive change, How do we harness that potential responsibly? Furthermore, the interplay between infinity and ethics raises questions about the value of individual lives in the face of overwhelming global issues. When confronted with the infinite needs of humanity, how do we prioritize our efforts? This dilemma echoes the existential reflections of philosophers like Simone de Beauvoir, who emphasized the importance of freedom and responsibility. Each choice becomes a testament to our values, shaping not only our lives, but also the lives of countless others. As we delve deeper into contemporary discussions on infinity, the contributions of thinkers like Manuel de Landa add new dimensions to our understanding. De Landa's work in assemblage theory emphasizes the dynamic nature of existence, where entities interact and evolve in complex ways. This perspective aligns with the idea of infinite relations, suggesting that the universe is not a static collection of objects, but a fluid interplay of forces and interactions. How does this understanding of infinity influence our ethical considerations? It encourages us to view ourselves as integral parts of a larger whole, where our actions are intimately connected to the fabric of existence. Infinity also invites us to consider the relationship between time and existence. If we adopt the notion of an infinite timeline, it raises profound questions about the nature of our experiences. Every moment we live can be seen as a single point within an endless continuum, where past, present, and future converge. This perspective invites contemplation on the significance of our choices. If time is infinite, does that render our experiences more or less meaningful? Philosophers like Henry Bergson have grappled with these ideas, proposing that time is not merely a linear progression, but a rich tapestry of lived experiences. Bergson's concept of duration emphasizes the qualitative aspects of time, urging us to appreciate the depth of our moments rather than merely measuring them. In this light, infinity becomes a reminder to savor each experience, acknowledging its place within the broader context of existence. As we explore these themes, we are reminded of the myriad ways infinity shapes our understanding of reality and our place within it. The philosophical debate surrounding infinity is not a distant academic exercise. It resonates with our lived experiences, prompting us to confront the mysteries of existence with both curiosity and reverence. How do we engage with the infinite in our daily lives? Are we aware of the potential for growth and transformation that lies within our actions? In contemplating infinity, we find a rich source of inspiration and inquiry, urging us to expand our horizons and embrace the unknown. Each question we pose serves as a stepping stone toward deeper understanding, illuminating the path ahead with the promise of discovery. The conversation around infinity is as boundless as the concept itself, inviting us to explore the depths of our humanity and the universe. As we stand at the intersection of philosophy, ethics, and the infinite, we recognize that our journey is far from over. The exploration of infinity continues to unfold, revealing new dimensions and challenges, beckoning us to engage with life's complexities. What awaits us beyond the horizon of our understanding? Perhaps it is here, in the heart of infinity, that we will discover the answers that resonate with our innermost questions, leading us to a profound appreciation of our place within this vast tapestry of existence. Chapter 10: Embracing the Infinite, Implications for Humanity. Understanding the concept of infinity profoundly shapes our worldview, inviting us to explore the very fabric of existence. Imagine standing in front of an endless horizon, the vastness stretching infinitely in every direction. This perspective instills a sense of humility and wonder, reminding us that our understanding is but a small fragment of a much greater whole. Infinity challenges our perceptions, encouraging us to look beyond the immediate and the finite. It prompts questions that resonate deeply within us. What lies beyond the limits of our comprehension? How do we fit into this infinite expanse? Through this lens, we can see how infinity influences not only our scientific pursuits, but also our cultural expressions. In the realm of art, infinity has been a source of inspiration for countless artists. The works of M.C. Escher, for instance, masterfully illustrate the interplay of infinite patterns and impossible constructions. His artwork invites viewers to contemplate the boundless possibilities of space and perspective, evoking a sense of curiosity and exploration. Imagine gazing at one of his pieces, where staircases ascend and descend in a never-ending loop, challenging your perception of reality. Such artistic expressions remind us that the infinite can be interpreted in myriad ways, each offering a unique glimpse into the human experience. Literature, too, has been profoundly influenced by the concept of infinity. Think of the works of Jorge Luis Borges, whose narratives often weave together themes of infinity, time, and the interconnectedness of existence. In his story, The Library of Babel, he imagines an infinite library containing every possible book, a metaphor for the vast potential of knowledge and creativity. His exploration of these themes invites us to ponder the nature of reality and the endless possibilities that lie within the written word. As we immerse ourselves in such narratives, we are reminded that infinity is not just a mathematical concept, but a canvas for the human imagination. The influence of infinity extends beyond the realms of art and literature. It permeates science and technology in profound ways. In physics, the concept of infinity has led to groundbreaking discoveries and theories. Consider the idea of singularities in black holes, where the laws of physics as we know them cease to function, and the fabric of space and time becomes infinitely dense. This phenomenon challenges our understanding of the universe and compels scientists to reconsider the very nature of existence. It raises questions about what happens at the edge of our knowledge. Can we truly grasp the infinite complexities that lie within the cosmos? In mathematics, the application of infinity is equally transformative. The development of calculus, with its limits and derivatives, allows us to explore the behavior of functions as they approach infinite values. This foundational concept has revolutionized how we understand change and motion, providing tools that enable engineers and scientists to design everything from bridges to spacecraft. Imagine the precision required to calculate the trajectory of a rocket as it journeys into the vastness of space. The principles of calculus, rooted in the understanding of infinity, empower us to venture beyond the confines of our earthly existence. Yet, as we embrace these infinite possibilities, we must also cultivate a mindset that welcomes uncertainty and exploration. The journey into the infinite is not merely about expanding our knowledge, but about fostering a sense of curiosity and wonder. How often do we allow ourselves to dream beyond the limits of our current understanding? In a world characterized by rapid change and complexity, embracing the idea of infinite possibilities can be a powerful catalyst for innovation and creativity. Consider the realm of technology, where the infinite potential of computing continues to reshape our lives. The principles of algorithms and data processing often hinge on concepts of infinity, allowing us to tackle problems that once seemed insurmountable. Imagine a world where artificial intelligence processes vast amounts of data in real time, learning and adapting at an exponential rate. This technological evolution challenges us to rethink our relationship with knowledge and understanding. What responsibilities do we hold as we harness these infinite capabilities? As we reflect on the implications of infinity for humanity, we find a shared thread weaving through all disciplines: an acknowledgement of our interconnectedness within this infinite tapestry. Each scientific discovery, artistic expression, and philosophical inquiry contributes to our collective understanding, reminding us that we are part of something much larger than ourselves. In the face of infinity, we are beckoned to explore, to question, and to embrace the unknown. Infinity invites us to expand our horizons, encouraging us to think beyond the conventional and to imagine what could be. It teaches us that the journey is just as important as the destination, and that within each moment lies the potential for infinite growth and discovery. As we stand on the precipice of understanding, we are left with a profound realization. Embracing the infinite is not merely an intellectual exercise, but a way of being. It encourages us to cultivate a sense of wonder, to seek out new experiences, and to remain open to the endless possibilities that await us. How can we foster an environment that nurtures this mindset? By encouraging curiosity in ourselves and in others, we pave the way for a brighter future, one where the infinite is not feared but celebrated. Imagine a world where every child is taught to dream without boundaries, where each individual is empowered to contribute to the collective knowledge of humanity. This vision is not just a dream, it is a possibility that lies within our reach. In every discipline, from the arts to the sciences, we are reminded that infinity is not a distant concept, but a fundamental aspect of our existence. It binds us together, urging us to explore, to question, and to dream. Each step we take toward understanding infinity enriches our lives, opening doors to new realms of thought and creativity. As we continue to embrace the infinite, we find ourselves at the intersection of knowledge and imagination. This place, where the boundaries of understanding blur, is where true innovation and creativity flourish. It is here that we can envision solutions to the challenges that lie ahead, drawing upon the infinite well of possibilities that surrounds us. The implications of infinity stretch far and wide, inviting us to reflect on our place in the universe. What does it mean to be part of something boundless? How can we contribute to this ever-expanding narrative of existence? Each question we pose is an invitation to engage with the infinite, to explore the depths of our understanding, and to recognize the beauty that lies within the unknown. As we embark on this journey together, let us carry the spirit of infinity in our hearts and minds. Let us remain open to the possibilities that await us, for in embracing the infinite, we also embrace the fullness of life itself. Each moment is a chance to discover, to create, and to connect with the world around us. The infinite beckons us, urging us to step into the unknown and explore the vast landscape of existence. As we contemplate the implications of infinity for humanity, we find ourselves at a pivotal intersection of thought and potential. The understanding of infinity reshapes not only our worldview, but also the way we engage with each other and the universe around us. Imagine a world where the infinite possibilities inspire collaboration rather than division. Such a mindset could foster a spirit of unity, where differences are embraced as unique contributions to a greater whole. Art, literature, and science, each enriched by the concept of infinity, serve as testaments to our desire to explore, to create, and to innovate. Think about the profound impact of the infinite in cultural narratives. From the philosophical musings of ancient thinkers to the modern expressions found in contemporary literature, the theme of infinity transcends time. It invites us to question not just what we know, but also what we have yet to discover. Each story, each painting, and each scientific breakthrough becomes a thread in the ever-expanding fabric of human understanding. Consider the works of artists and authors who have ventured into the realms of the infinite. Their creations resonate with the echoes of curiosity and exploration. The poet Rainer Maria Rilke, in his Reflections on Existence, reminds us that the only journey is the one within. Such insights urge us to look beyond the tangible, igniting a flame of imagination that propels us toward the infinite possibilities of our own lives. In the realm of science, the practical applications of infinity extend far beyond theoretical constructs. The principles of quantum mechanics, for instance, hinge on an understanding of probabilities that can stretch toward infinity. Picture the behavior of particles at the quantum level, where possibilities overlap and intertwine in a delicate dance of uncertainty. This infinite realm of potential shapes not only our understanding of the microscopic universe, but also informs technological advancements in computing and communication. Imagine harnessing the power of quantum computing, where the intricacies of infinity unlock unparalleled processing capabilities, revolutionizing industries and transforming the way we interact with technology. As we venture further into the implications of infinity, we also encounter the ethical responsibilities that come with such expansive knowledge. How do we ensure that the pursuit of infinite possibilities is guided by a commitment to humanity and our shared ethical considerations? The infinite potential of technology, while promising, also presents challenges that require careful deliberation. The questions we must ask ourselves are vital. How can we harness these advancements to enhance the human experience? What frameworks can we establish to ensure that the infinite is used for the greater good? Embracing a mindset that celebrates infinite possibilities encourages us to dream bigger, to push boundaries, and to redefine our limitations. Imagine a society where education emphasizes the exploration of infinite potential, where curiosity is nurtured from a young age, and innovation is celebrated as a shared human endeavor. In such a world, the barriers that often separate disciplines would dissolve, allowing for cross-pollination of ideas and collaborative problem-solving. The beauty of infinity lies in its invitation to explore the unknown. It challenges us to step outside of our comfort zones, to question the status quo, and to embrace the complexities of life. This journey into the infinite is not just about acquiring knowledge. It is about fostering a profound understanding of our interconnectedness with one another and the universe. Each step taken toward embracing infinity is a step toward recognizing our role in the larger narrative of existence. Consider the implications for future generations. How might they perceive the infinite? Will they view it as a source of inspiration, or will they be daunted by its vastness? It is our responsibility to cultivate a culture of curiosity and wonder, one that encourages exploration and celebrates the pursuit of knowledge. By doing so, we empower future thinkers, creators, and innovators to engage with the infinite with confidence and enthusiasm. As we reflect upon the implications of infinity, we are reminded that this concept is more than an abstract idea. It is a vital part of the human experience. Each individual has the potential to contribute to the infinite tapestry of existence, adding their unique thread to the larger narrative. The richness of our collective knowledge, shaped by diverse perspectives and experiences, enhances our understanding of the world and our place within it. In this era of rapid change and uncertainty, embracing infinite possibilities can serve as a guiding principle. It encourages resilience in the face of challenges and inspires hope for the future. Imagine a world where every obstacle is viewed not as a barrier, but as an opportunity for growth and innovation. This shift in perspective can propel humanity forward, fostering a sense of purpose and direction amid the vastness of the infinite. As we continue our journey through the implications of infinity, let us hold onto the vision of a world where the infinite is embraced, celebrated, and explored. The beauty of existence lies in its endless potential, and our ability to dream, to create, and to connect with one another is a testament to the power of infinity. Each moment is an invitation to discover, to learn, and to celebrate the infinite possibilities that await us. In this embrace of the infinite, we find not only understanding, but also a profound appreciation for the journey of life itself.